Today we're going to talk about reflections. This is another one of the transformations that we started talking about with our translations. A reflection, though, creates the mirror image of the original. The reflection occurs over what we call the line of reflection, also sometimes called the line of symmetry. A reflection from the old days is also known as a flip. So we talk about taking the shape and flipping it across the line of reflection. So notice here we have this shape. When I flip it across the line, notice how this slanted line is now on this side. The straight line here is now over on this side. But our size hasn't changed and our shape hasn't changed. So it's important to notice that both those things are still true. But it is definitely now a mirror image or flipped across that line of reflection. So let's talk about how we identify these. So looking at the two shapes, would you say that this is a reflection or not a reflection? Yes, this one definitely is a reflection. And I know that this one's a reflection because, again, we have the line there, and the distance that I have from this point right here to the line is the same as this distance. This point's distance to that line is the same down below. The same thing here. This point's distance goes straight down over the reflection to that point, and the last point, that distance is the same as that distance. So I know it is a reflection. Still gives me the same size and shape. On this next one, what do you think? Liner, is this a reflection or not a reflection? Right, this one is not a reflection. We would have to say no. This would actually be a translation. Back from the last section, remember we took a shape and we just slid it across the paper? This would definitely be a translation because the size and shape still stays the same, but not a reflection. The way I can see that on here is, again, this point right here, is this far from the reflection, that line of reflection? It needs to be about this far over here. And again, this one is this distance, so it would have to come out this way, which maybe this one is, but this tip right here is definitely a lot further on the other side. So that would help me decide that this is definitely not a reflection. So like we did with the translations, this next thing is important to kind of understand how these reflections work. So in words, what we're going to do is move each of the vertices so it's the same distance from the line of reflection on both sides. When we talk about how we move these things, we talk about moving them in the x-axis, which basically means that the x-axis is our line of reflection. So remember, this would be our x-axis. So if I reflect it in the x-axis, I'd be flipping a shape from, for example, here over the x-axis down. The other thing that we will talk about is reflecting in the y-axis, which, as you can imagine, is the same as we just mentioned, except that instead of going over the x-axis, now you'd be doing your reflection for here, for example, over the y-axis, bringing my shape from the left side over to the right side. So that's how we refer to reflections, in the x-axis or in the y-axis. Now, you will also be learning when you get to geometry at the high school how you can also reflect over any line. And you can do that over different equations. Once you've made the graph, you do the reflections. We're basically going to focus on the x-axis and the y-axis this year. So again, notice the tick marks. So notice this right here tells me triangle ABC. This is my original. This one was reflected in the x-axis to drop it down here, to turn it into A prime, B prime, and C prime. That would tell me that's the first image point. Now I also could have taken this, again, the original, and gone over the y-axis to become the same ABC triangle, but again, notice that it's the same size and shape, but it doesn't have that same look. I didn't just slide it across. The distance between here and here is the same over these 2 points, but notice now I'm calling them A double prime, B double prime, C double prime. That's because we've already used A prime, B prime, and C prime. So just like anything, once you've used the label, you have to consider using a different label so it's not confusing to your readers, but that's why those are there. So let's just kind of see how that actually played out. In the algebraic look, my original pairs, when I go across the x-axis, this is what happens to my points. The x is going to stay the same. And whatever y was is going to go to the opposite. That's what negative y means. So let's just take an example. And I'm not going to do all of them, but here's A. The ordered pair for A is at -3, 1. In the x-axis, A prime, which is sitting from A down to A prime, is sitting at, this one's -3, but now it's at -1. So notice the distance is the exact same distance above and below the x-axis. So notice that the -3 didn't change. But what did change was that the 1 from A is now turned into a -1 for the A prime. Then when I go to in the y-axis, so in the y-axis, when this happens, now the x is going to be doing the opposite thing, but the y is going to stay the same. So when I do this one, let's go again for example A. We said it was -3, 1. So here it is at -3, 1. This time when I flip it across the y-axis, notice that it's going to go 3 here. So it goes 3 here. But notice now the ordered pair over here, it's not -3 anymore. A double prime is now a +3, but it's still sitting at the 1 for the height for the y. I don't want you to stress about this piece down the middle with the algebraic part. If it doesn't really make a whole lot of sense, it's more important that you understand how to move these points and to create the reflections by moving them across correctly. Whether you understand the algebraic wise is not as important. Eventually that'll come with more practice. So now we want to talk about reflecting and how we actually do one. So we have the vertices A, B, C. We want to draw the figure, so that's important to notice, and its reflection in 2 ways. One, in the x-axis, and then the second one in the y-axis, and what are the coordinates of the image. So we're going to do this 2 ways. So there's the A, and then we'll do the B. So in the x-axis, so the first thing I need to do is draw my triangle. So just pause the video, draw the triangle, give the ordered pairs to that, and then turn it back on and we can see where we go. So there's my triangle A, B, C, and notice how I put the labels on them because it's very important that we do that. Now we want to draw the figure that's been reflected in the x-axis. Now remember, the x-axis is this one right here. This is my x-axis, which means that I'm going to be folding this shape downward across the x-axis. So I'm just going to make a quick little note here to remind myself the x and the y. So when I do my points, what I'm going to do is go to each of these points. So A, for example, starts here. To the line of reflection is 1 point, so I go 1 below it. So that tells me that this one is now A prime. I do the same thing with my B. This time it's 4 down to that line, so I go down 4, and I can plot that point right there. It's now called B prime. C is also 4, so I just count straight down, and there's C prime. I connect the dots, and there's my triangle that's been reflected over the x-axis, meaning it's been flipped downward. So to answer my question completely, they wanted to know the coordinates, so A prime is sitting at 1, -1. B prime is sitting at 1, -4. C prime is sitting at 3, -4. On the next one. So again, pause the video and draw the triangle first, and then we'll go from there. So there's our triangle again, A, B, and C. This time we're reflecting over the y-axis. So the y-axis is the taller, longer one. So if I'm reflecting it over this one, that means I'm going to take the shape here on the right and flip it across to the left. So again, just like we did, I go to each point. This is one away from the line of reflection, so I go one away on the opposite side. And there is A prime. B is one away on one side, so I go one away on the other side. There's B prime. And then C is 1, 2, 3 away, so I go 1, 2, 3 on the other side to get C prime. And again, I need to connect the dots. Notice the triangle is the same size, it is still the same shape, but it's now been flipped across the y-axis. And I want you to also notice here, sometimes we get people to label these incorrectly. So over here it's C prime, B prime, this one's B, C. So notice how the B and the C's have kind of flopped left and right. And the last part is we're supposed to be giving the coordinates. A prime is it sitting negative 1, 1. B prime is sitting at negative 1, 4. C prime is sitting at negative 3, 4. So lastly, we have an artistic design of a t-shirt that is using a pentagon with vertices of the following P, Q, R, S, and T. The artist reflects the pentagon in the y-axis to create the design. Find the coordinates of the reflected image and then draw. Okay, so what I want you to do first is let's plot the P, Q, R, S, and T. Pause the video and then come back on to see that we're all in the same spot. So just plot those points first. So hopefully we all have the same thing here. We have this kind of pentagon, which it is a pentagon because remember a pentagon just means 5-sided straight lines, don't cross over, closed figure. So this is a pentagon. It doesn't look like our traditional one, but it is. Then we want to do a reflection. And how are we reflecting it? We're reflecting it, so I would make a note here, reflect in the y-axis. So reflecting on the y-axis means that it's going to go from left side to right side or right side to left side. Because remember the y-axis is this one right here. So it's going to flip across to this side. So all I'm going to do is just go point by point. So P is not anywhere off of the line of reflection. It's actually sitting right on it. So this P point is actually just going to stay as P prime. Then when I look at Q, it's going to come 2 units to the left, so I'm going to go 2 units to the right to get Q prime. Looking at R, I would go 1 across and then come across 1. There's your R point. Then S is 4 to the left, so I would go 4 to the right to plot that point. And then T, again, just like P, isn't off of that line of reflection, so it's just going to stay right there and still really kind of be T prime. So really, if I just connect all of these dots, there is the shape that we're kind of looking for. It's like an arrow. And the last part says is to find the coordinates of the reflected image. So P prime, Q prime, R prime, S prime, and T prime. P and P prime are at 0, 0, so they haven't changed. Q prime is now at 2, 0. R prime is at 1, 3. S prime is at 4, 3. And T prime, just like regular T, is at 0, 7. So that's how we do a reflection. I think it's not completely straightforward, but as long as you understand that the x-axis we go up and down when we do our reflections, the y-axis would tell us to go left and right. So if that line of reflection is the y-axis, it's telling us to go left and right. If the line of reflection is an x-axis, we're going to be going from up to bottom or bottom back up to top. If you have any kind of questions, please feel free to ask next time I see you in class.